Hi, hello everyone. So today we are going to discuss about Kirchoff laws. Kirchoff laws or Kirchoff rules. So here two rules are present. First one is junction rule. Junction rule or current rule. So right. So according to junction rule, so mainly in this rule explains it is a junction. Junction means two or more wires are connected at a single point, that is called as junction. Right. For example, this is one wire, this is another wire, it is another wire. So number of wires are present. So here this current, this wire is connected here, this wire, all five wires are present. These five wires are connected at a point, single point, that is called as junction. Right. So now here direction of current in different wires as like this. So now here, for example, here consider I1 current is passes through this wire, I2 current is passes through this wire, I3 is current is passes through this wire, I4 current, I5 current, like that only consider. So all currents, current values, I1 means here 1 ampere, 5 amperes, 6 amperes. So here 3 amperes, it is 2 amperes, like that only consider. So that is the magnitude values. So here algebraic sum of current at any junction is 0. So that is definition. So now according to this, how much current is passing through this wire? Same amount of current is passing, that means leaving from this junction. That is a general definition. So according to this, so here with some we assume sign convention like this. So observe here. So now sum of current entering into the junction is equal to sum of the current leaving from the junction. Leaving from the junction. So this is original definition. Sum of the current entering into the junction means what currents are entering? I1 plus I2 only entering. How much current is leaving? I3, I4, I5. So this is according to main statement. So how much current is entering? How much current is entering means I1, I2 only entering. Same amount of current only leaving only. So for example, in water line on water pipe only consider. How much water? 1 inch water can be entered into the junction. Junction means here three pipes are connected from these two wire pipes. So now how much water is entering means same amount of water only leaving, same like that current also. Here for example, household appliances, from main supply two wires only will come. So here 240 voltage. So like that current only passes. So from the meter, so number of devices will connect in our household. So all devices can be utilized same amount of current only. No, it can be utilized more amount of current. No, it is impossible. Why? Because entering current how much is there? Same amount of current only it can be utilized. That is the meaning of this definition. Sum of current entering into the junction equal to same amount of current, total current is equal. So that is the I3 plus I4 plus I5. So now here I1 plus I2 minus I3 minus I4 minus I5 equal to 0. So now here observe here. So how much current is leaving, how much current, both are equal only. No? Equal means same amount of equal means subtraction what happens? 0 will come. 0. So that is Another definition is there: algebraic sum of current at any junction is 0. It is another definition. Algebraic sum of current at any junction is 0. So I had to write in exam any one definition, any this one or this one. So it is simple. Algebraic sum of current at any junction is 0. This is the example for equation. Right. So it is also simply written as summation of I is equal to 0. So this is the equation. Next. So Kirchoff's junction rule significance is it works on the principle, otherwise it is obeys law of conservation charge. So this is the significance of first rule. Okay, got it, Nana? Right. I'll give one example. Okay, written. Right. Next. For example, so this is one wire, it is another wire, it is another wire. So it can be passes 1 ampere current, it is passes 2 ampere current. It passes how much current? Sum of these two, so 3 amperes only. Sum of the current enter into the junction equal to sum of the current leaving from the junction. That's why 1 plus 2 is equal to 3. Same current. Same like that. For example, this one. So here 2 amperes, here 5 amperes, here I how much don't know. This is 6 amperes. Like that only consider. So how to solve this I value how much? For example, here entering, it is a junction. Entering the junction means what currents? 5, arrow mark only we should observe. 2 and 5 entering, and I and 6 is leaving from the junction. So that's why 2 plus 5 is equal to I plus 6. Clear? So now here 2 plus 5 is 7 is equal to I plus 6. So I is equal to what? 7 minus 6, that equal to 1. So I is equal to 1 ampere current is passes. Very clear? So how much current is entering? 2 plus 5 is 7. 6 plus 1 remaining is 7 only. Na? So that's why 1 ampere current is passes. Clear? Right. Right. Next one is second. Second rule. Kirchoff's second law, otherwise voltage law. Voltage law or loop law. Kirchoff's loop law. So loop means here closed loop. No. Closed loop is compulsory. It obeys only closed loops, not open loops. Open loops, closed loops means, for example, it is open loop. So it is closed loop. Closed circuit or closed loop. So it is closed loop. It is open loop. So there is no connection between these two wires. That's why it is open loop. But it is obeys. Second law only obeys loop law. Loop means closed circuit. Right. Now, so according to this voltage law, so the algebraic sum of potential difference at any closed loop is 0. Clear? Algebraic sum of potential difference at any closed loop is 0. That means summation of delta V is equal to 0. This is the according to statement equation. So delta V means what? Potential difference. Potential difference means IR. Here two conditions are very important. Clearly observe here. So now when it is a resistance. Potential means what? V is equal to what? I into R. Potential or voltage means it is multiplication of current and resistance. That combination is called as voltage or potential, right? So now here it is the resistance, it is the current. So it is path followed. So here it is A to B only consider. So direction is A to B. Direction of loop. This path, it is the path. So path is A to B. So in a loop, one side only you should consider. For example, this one. It is A to B, B to C, C to D, D to E. That is a closed path. So now observe here, current direction is like this. Right, it is E. Clearly observe, Nana? Very important points, basic points. Observe here. Path means from here to here. In a loop, A to B. This only separated here. It is R. Otherwise R1, R2, R3 only consider. It is R1 only consider. So path direction, current direction should be observed. Same direction means here again two conditions are there. Any one we should follow. Any one only should follow entire circuit. So you should take second rule means second rule only should follow. First rule means first rule only we should follow. What is the rules? First now, current is passing from A to B, path direction. Current direction and also path direction both are in same direction. This direction, same direction. That's why here it is. First main thing is here high potential, it is low potential. Why? Because already it is basic thing. Whenever current passes through the resistor, then current value will be decreases. Why? Resistance will be opposes the flow of current. So that is the definition of resistance. So opposes means decreases only. That's why potential is a potential difference between VAB, A to B means, so V is equal to minus IR1. It is original thing. So how much current is passes? I current. What is the resistance? R1. Why it is minus? When current is passes from here to here, the same direction, it is can be opposite. That's why minus. That is general thing. But in some cases, some books are followed by, so current direction of the path both are in same direction means, so V is equal to plus IR1 only we should consider. So this one are correct, this one also correct, but it is original according to concept minus IR1 is correct. So but for easy way purpose, some cases some books are followed like this way. So same direction, current direction, path direction same means plus. So path direction, current direction opposite means minus. Like that only we should consider. So that only I told first. So you should follow any one, this one or this one. It is concept related. It is our convenient way. So both are correct only. We should apply this one or this one for entire circuit. So one time we should consider like this, another way, another time we should consider like this means it is mistake. Are you clear? Right. So now this is main thing. Next one is cell is there, cell related. So resistance means like this only we should follow. V equal to minus IR1, otherwise plus IR1. So here clockwise only A to B like this only consider. So path direction this one. path direction, current direction, both are same, right? So now EMF, cell related, for example it is cell, it is, for example, is it D, it is A only consider, D to A. So D side what, negative terminal is there, right? Negative terminal, D side, A side positive terminal is there. Positive terminals always we should consider high voltage, it is low voltage. Current direction, it is current. Current direction is this one. Here, it is not depends on path. Clearly observe here. EMF. EMF means total potential difference. Potential difference is not depends on path here. So it is directly potential difference is there, no resistance. That's why here E is not depends on path. So either this direction or this direction, path direction, any direction it can, but current only important. Current is passes from negative to positive or positive to negative. That only you can observe in terms of potential difference of EMF, total net potential, this one, right? So observe here. So whenever current is passes from negative terminal to positive terminal, so here potential difference is positive. That means plus E. Very clear, right? So any direction, this one only, but current is passes. So the next example is, for example, here positive, it is negative. Current is passes like this way. Observe these two, observe and compare these two. Here negative to positive side, current direction is negative to positive, that's why it is positive. Next here current direction is from positive to negative, positive to negative. Positive to negative means potential difference is minus E, low. High potential to low potential means negative. Low potential to high potential is positive. That's fixed. So don't observe path direction. Path is D to A. It is positive. That's why positive. It is not correct. So path is not depends. Here only current direction only we should consider. Current is passes from negative to positive or positive to negative. That only important. Clear? Right. So next one is, for this loop, total potential we want to calculate. See here. First for loop A, B, C, D, A. So A closing points. A to B, B to C, C to D means it is open circuit. D to A is also means it is closed loop. Right? First we should observe A to B. A to B. A to B means what? Same direction. So according to first condition, I observe, that means taken. That's why here minus IR1. Clear? Minus IR. Next, B to C. B to C. B to C means what? Same direction. Path direction and current direction. Both are in same direction. That's why minus IR2. Next, C to D. C to D. C to D. Path direction, current direction. Both are in same. That's why minus IR3. Next, D to A. D to A. D to A. D to A is what? Path direction don't want to consider. Only current direction. Current direction means from where to where? Negative to positive. That's why plus C is equal to what? 0. That's second law application. Right. Next same thing. For example, second condition. So R. Second condition we should consider. Second condition is what? Path direction, current direction. Same means plus. That is second. R. Any one only should follow. This one or next one. So plus IR1. Next one, this one, B to C, current direction, path direction, both are in same. So place IR2. Next, place IR3. Next, plus C only, plus C equal to 0. Same direction means same, not opposite direction is not one. So here it is always positive. Why? Because current passes from negative to positive direction, positive terminal. That's it. It is for clockwise. Clear? Right. For example, here anti-clockwise only you should consider. Path direction means anti-clockwise. Anti-clockwise. Anti-clockwise means, for example, anti-clockwise means A to D. A to D means from here to here like this. A to D, D to C, C to B, B to A. A to D, D to C, C to B, B to A. So it is anti-clockwise. You want to say? A to D, path direction don't want to consider. So that's why here current direction only we should consider. Current direction is what? Negative to positive only. So that's why it is plus C only. That's very, very important. Clearly observe. It is clockwise, but it is anti-clockwise. It is clockwise means what? Path. Anti-clockwise means what? Path. But here A to D means actually path direction A to D, A to D, A to D. But the path current direction is D to A. So that's why here current direction only required. Path direction don't want to consider for this type of cases. Means cells. Right. Next, D to C. A to D over. D to C. D to C. Current direction is C to D, but our direction is D to C. D to C means what? Opposite. First condition is what? Same direction means minus. Opposite direction means plus. So place IR3. Are clear? Right. Next, C to B, but path direction. C to B is path direction, but current direction is B to C. So that's why here place IR2. Next, path direction is B to A. B to A. But the current direction is A to B. So that's why place IR1 equal to 0. This is according to first case, first condition. If second condition means OR. So here A to D, it is everything always positive one. Next, D to C, D to C. D to C what? Generally clockwise means what? Plus. So it is anti-clockwise. So anti-clockwise means what? Minus will come. Minus IR3. Reverse one. Minus IR2. Minus IR1 equal to 0. Are you clear? Observe these two. It is anti-clockwise, but it is clockwise. Understood? Reverse will come. Reverse. Here minus means plus, plus means minus. But two conditions. So don't confuse. You should follow any one. Any one. Any one means this one. Whenever current is passes through the resistance means minus along the same direction. When current is passes opposite to the path direction plus. That is main observation. No sir. So I will follow positive related means same direction means positive, opposite direction means negative like that. So here opposite direction, loop direction and current direction opposite. That's a minus. So C to D. C to D means positive. Now that means negative. But opposite direction means positive. Okay? Clear? Right. Okay. Thank you.